Hello, and welcome to the Mr. 50mm YouTube channel. I'm Mr. 50mm and Mr. DIY, also Chris. Today, I wanted to share some stuff with everyone. I'm always sharing stuff with everyone, but this is a little bit different. This time, I want to share some projects that I made in the past. However, unlike the majority of most of my DIY stuff, where I tend to release the files, give plenty of detail on how they work, for most of these projects, I do not remember the specifics of how I made these. And we'll also go over one other thing, which is an honorable mention. Let's have a look. The audio trigger. This thing is where it started. It started with a small obsession with things that were to be made to fit inside Altoid tins. Along with that, I remember that when I was doing this specific project, I had one other main goal, and that was to design a thing without using a microcontroller, with the secondary goal being to fit in an Altoids tin, which it does. Mind you, when I started this project, this was almost immediately after I graduated university, so it was a long, long time ago. As a result, I don't exactly remember what I did to build this thing, but I do generally remember the functional blocks. Let's have a look. First, you can see there's a knob. This right here, that is a potentiometer. Down here, we have a 3.5mm headphone jack. That's where the output is triggered to, or that's where the trigger output is. Looking inside, in theory, I could take this thing and copy it part by part, and that might probably jog my memory on specifically how this thing works. However, let's go over what we can see right now. There is a microphone. It is right there. It's a simple, or it's connected to a simple 2-transistor audio amplifier, and that amplified signal is then sent to a comparator. That's where the signal is compared against a trigger voltage, which, if I remember, was determined by using a voltage divider with one of the resistors and this potentiometer. And that allows the trigger voltage, or the volume level where it's triggered at, to be variable by twisting this. And I know what you're thinking. How sensitive is the trigger? Well, there is another dedicated IC, I believe this one here, and its entire thing is to light up a row of LEDs based on two things: an input reference voltage and the input voltage you want it to compare against, and that will fill up the LED bar based on your input reference. So it's actually probably hard to see, but it should have been going up and down since we've been speaking. So this gets us to the triggering, but I also thought it would be cool that when we have the trigger, that we could control a trigger delay in case the action that I wanted to capture wasn't exactly at the moment that the sound was heard. And this is achieved here. Oh, that is a 555 timer. And this, below it, is a series of resistors which could be activated by that dip switch there. And the combinations would give you different delays based on inputs going to the 555 timer. Additionally, apparently I also had the wherewithal to do notes here, which allow me to have delays of up to 1.01 seconds, or as little as no seconds, plus other times in between. Additionally, this bottom slot, or the bottom dip switch, is the power switch for this device. If I remember properly, the actual trigger mechanism was pretty janky. From what I remember, the triggering section is wired up here where the headphone jack is, but it basically holds the output high, and then the other side of the wiring is grounded, and when it's triggered, or sorry, let's back up a bit. When it's just plugged in and nothing's triggered, it appears to be an open circuit with 1 voltage at the other side and ground on the other. When it's triggered, I believe what I do is that the output is then dropped and it appears to be a short, and that triggers the 3.5mm jack, and generally whatever you're planning to trigger, whether that be a flash or a camera. Something to that effect. I don't specifically remember. All I do remember is that the system is kind of janky and it doesn't always work with all cameras and flashes because I had incorrectly judged the required voltage to be considered an open circuit. At any rate, it's a terrible way to trigger things, but it works. Lastly, you may have noticed there is a cheap 9-volt battery, and this is powering the whole thing via a 5-volt regulator. Hooray! And needless to say, all this work that went into designing this thing resulted in exactly 1 photo being done sometime in 2012 before I moved into another project. Actually, it's not entirely true. I at one point used this thing at a friend's party. We set up my 5D2 where everyone was hanging out, and if we got rowdy enough, the camera would snap a photo of the moment. I think that night, the camera snapped hundreds of photos. Otherwise, let's look at the photo I actually successfully set up using this device. I believe it was popping a balloon with a dart. A classic audio trigger scenario. Otherwise, let us demonstrate the audio trigger now. I have here a Rebel XT. I'm going to plug in the 2.5mm trigger port into the XT. I'm going to turn it on. Actually, yes. I'm going to now plug it into this thing. And I'm going to remove the body cap. I'm going to turn it on, and here. Hopefully everyone can see the Rebel XT. I'll make a loud noise now. Click. Wait. No! The XT battery is dead. Let us try that again momentarily. Okay, so now let's have a look. Battery is in the Rebel XT. There's the trigger. I'm going to make noise. Click, click, click. Or I guess snap. I don't know. Yes, you can see the thing is triggering, and when I normally speak, it does not trigger. But when I make a loud enough noise, oh, apparently like that, it goes. Click. Neat stuff. Whoa. All right. I'm turning that off. The motion trigger. This is stored in a blue Altoids tin. The audio trigger was in a red one. Shortly after I built the audio trigger, I was wondering if I could do the same thing with light, basically a motion trigger of some sort. I remember this being a quicker build than the audio trigger, and part of that was because I used some of the same elements from the audio trigger to speed up development. For example, the output was the same 3.5mm headphone jack. The power was the same 9-volt pack with a 5-volt regulator, and overall, a couple things were carried over, like the use of a 555 timer and a dip switch thingy to control some timings. It is at this point that I do want to say that in hindsight, I probably should have just bought one of those PIR sensors. Those are the motion triggers you commonly see that turn on lights or detect movement in general. However, at the time, if I remember right, those were around $15 for a unit, and I figure I could use photocells, these things, which come at something like 25 cents a piece, so much cheaper. And again, I set out not to use a microcontroller. So all of this is otherwise discrete logic. Somehow I thought that programming would be cheating. Somehow. Not really sure why in my mind, but that's what I thought. Now, unfortunately, my memory is a bit fuzzier on this project, but effectively I had these two photodiodes, and they're placed directly beside each other. And there's a point to that. And basically the idea is if this thing detected that, or what it did was that it measured the light levels from both sensors. And if it detected that one sensor dropped very quickly compared to another, it would trigger the system to fire. It's, again, a triggering system similar to the audio one, except I think actually made the trigger mechanism itself a bit more robust, and it will work with almost anything, as I believe I tuned the output to be a little less janky. All right, before we move on, I'll demonstrate this. Now, what I have realized is trying to do it in the video recording environment is interesting because I have to tune the system to work with all the lights that are basically pointing at it and coming at various different weird angles. But I think I've got it. And what you'll notice is that when I move my hand over the two photosensors, the LEDs here, one of them will blink, and that'll indicate it's triggering. There you go. Hooray. At any rate, this project, as I said, also includes a 555 timer that is over here. And there is a little dip switch here full of resistors. However, I forgot to put in a little cheat sheet to remind me what the delays were. So I'll have to just randomly play with them and see what delays I get. In the end, though, hilariously, I never actually used this for a photo, if I remember this right. But I envisioned this as something of a little bit of a trail cam trigger that would activate when something like an animal crossed it, and then my camera would fire and take a photo. But again, I never really ended up using it for that purpose. Now let us plug it in and see if I can get this to trigger based on the motion. All right, so we're gonna point it here. I'm gonna move the camera directly in front. Oh boy. Weird. It should be firing. It is not doing that. Well, not all the projects are winners, I suppose. All right, there we go. For some reason, this one isn't working as nicely. It seems to be a little intermittent. All right, I guess I have to adjust the sensitivity a bit. Maybe that's why I didn't end up using it. This thing is not as reliable as I would like it to be. But overall, I think it's still a pretty interesting project. I'm going to see if I can trigger this flash with the little thing. I'm going to move my hand over the sensors and hopefully that should fire it. I don't know if you're getting that, but it is definitely flashing. Neat. So it works. All right. I've got to turn that off now because now it's just basically triggering when I move it over my lights. The microcontroller audio trigger. Sometime a few years after making these Altoid-based things, in 2014-ish, I decided I wanted to make a system that is more versatile, something where I could more easily customize the way that the system reacted once triggered. So I folded, and I eventually decided that this would require the use of a microcontroller, the old darling of microcontrollers, the Arduino, specifically a Nano for those who care. With a microcontroller, I was able to integrate something like a 2-line character display. It has 4 unlabeled buttons for extra chaos, and a microphone, obviously, because this was a audio trigger. The microphone was actually, or the implementation of the microphone was actually pretty similar to the other project. I used a cheap little a cheap 2-pin microphone thingy and a simple 2-transistor amplifier. And it would just feed that analog reading into the Arduino directly. The rest is mainly just software and interface bits. And the trigger is now controlled by an Arduino and can be set by a program. The display constantly outputs an arbitrary value for what it's reading and what the trigger point is. So you can manipulate it and move that trigger point up and down depending on how sensitive you need your pickup to be. With all the fancy power of a microcontroller, it could also do things like introduce specific delays. So this is currently on delays in milliseconds, and I can increment that in 10 millisecond increments. But I can also scroll through, and I can go seconds. I can also do minutes, and I could also set repetitions. So I could basically set it as an intervalometer. Once it's triggered, how many seconds or what time between triggerings do you want it to trigger at? And the next value over is how many times you want it to do it. So if it triggered and had a 90 millisecond delay, it would fire once, wait for the repetition duration, and fire X amount of time. So right now it's only at 1. So yeah, generally a very versatile system. Overall, this is actually a pretty nice system to use. And you may have noticed that the case is 3D printed. Hilariously enough, the case was made with 3D print waste. At the time that I made this, I bought a very, very cheap entry-level 3D printer at the time. It's crazy because I think I paid around $600 for this mostly crappy 3D printer. I was constantly tinkering, repairing, and trying to get it just to print anything properly. It had an insane number of issues. And it's crazy to think that nowadays you can walk into most, or like computer shops, at least in here in Canada land, Canada Computers, walk out with a fully functional 3D printer for something like $130. Anyways, that is a tangent. But yes, this is made with failed 3D prints, large hollow segments that never completed one way or another. Anyways, interesting thing of recycling, for me at least. One thing that was kind of interesting about using a microcontroller and using this 3D print waste was that I, for some reason, decided that a lot of things needed to be outside the case. For example, this power connector, which is normally used to plug in a 9-volt battery, is on the outside. It's currently just being powered by, oh no, a USB power bank, and I've dropped it. But it is meant for a 9-volt battery. And additionally, the 3.5mm headphone jack is, again, also just glued in on the outside, or glued out of the actual project case. The sad thing is, I've only kind of just begun using this again to facilitate actually some flash reviews. I found a way to automate some of my testing using this device. But I realized more than 10 years after building this thing, my code has bugs, and that code is long gone. I do not know if that file is around anywhere. So I think I'll have to rebuild it from scratch if I want to figure this out. But effectively, what happens sometimes is if I set an interval with a number of times I want it to react after triggering, it doesn't always trigger the number of times that I put on screen. Sometimes it does, sometimes it doesn't. I actually have no idea why it would do that, but that's just how it is. And that's, I guess, how it's going to be. Quick demo time. So what I've done is I've set it up so that it will trigger at some audio level that is a little higher than the bass I normally have it set to, so I can speak. And it's going to fire the flash 3 times every 2 seconds, hopefully, as long as the code doesn't decide to not do that. All right, I will hold it up. Hopefully you can see it right there. And I have a flash. You're going to get some bright flashes. Flash! Nope, not, okay. Huh, see? That was one of those times where it decided that it did not want to do it multiple times. Let's try it again. And that other time it worked. So I don't know what causes this bug. Neat demo. An honorable mention. So the last one is actually a project I made pretty recently, and I made it after manufacturers kept reaching out to have me review flashes. You may have watched the videos, but if you haven't, that's fine. But know that I like to test claims. One of the claims that comes up pretty often is just battery life. So obviously I could have just sat there and count flash pops, but that's kind of crazy. So I thought of a new or a different thing. How about I make a little system based on an Arduino and a cheap graphic display with a very cheap light sensor that just detects flashes and counts it up. That's all it does. That way, I didn't have to actually count things. I could just press the button. However, as of doing this video, I figured out that I could reuse this older project, the audio trigger, and basically set it up in a way that I can fully automate the flash battery rundown test. And I have tried it now twice as of the time of this recording, and it's awesome. The first time it ran down the flash to like 650 shots or so, and the second time it popped the flash 1,200 times. And it was still going. Flash died, but the system worked, so awesome. Anyways, now I want to, actually no, I should actually show you the thing first. This is it. You may have seen it before in the photos. There's the display, there's a little cheap photo sensor, there's the Arduino. That's it. But quick question for you, do you do any DIY stuff for photography? If so, let me know what you've done and if you've had any failures or not. Otherwise, as always, don't forget to like, comment, and subscribe. Maybe a super thanks if you're into that. Till next time, bye.